Alright, so let's do lecture 11 part 2. So this is about functions, compositions, and most importantly domains. We pay a lot of attention to domains in this class, and not just this class, even in calculus, in calculus 1 2 3, all those calculus lectures, domain is, it plays a really important thing. I mean, even in higher mathematics. So let's talk about functions, operations, compositions, and the domains. So things we learn, if you add it, subtract it, multiply it, the domain is just the intersection. So that's the easiest thing possible. Okay, so we can just find the domain for these two functions. So the domain of f is everything but -1. So that would be x plus 1 not equals 0. That would be x not equals -1. In interval notation, that would be negative infinity to 1, -1 to -1 to infinity. Okay, so that's the domain of the function f. The domain of the function g is, well, it's a polynomial, it's a linear function, there's nothing, no restriction, so that's all real numbers. Okay, for some reason this is just blurry. Okay, okay, so just think of adjusting things. Okay, never mind, let's keep it like this. Probably hold it closer, I guess. Okay, so sorry about that. Now, so the domain is this and this. So the intersection, let's just draw things in different colors. So the domain of f, I would just do it in blue. So that would be everything but -1 in blue here and in blue here. And the domain of g in red. And you can see the intersection, which is with both blue and red, that would be everything from -infinity to -1, and then 1 to -1 to infinity. So -infinity, -1, and then -1 to infinity. So the intersection. So we know that the domain of fg is the intersection of the domains of f and g. That would be -infinity to -1 union -1 to infinity. So the question was find the domain. I found the domain, but let me just look at the actual product. Okay, so f times gx is equal to, just take the product, so fx times gx, that's a solid dot here, so fx is 3x over x plus 1 and gx is 4x plus 4, where 4x plus 4. Okay, and that would be 3x over x plus 1, and this you can take out 4, so 4 times x plus 1. And what you can see here is actually, well, this is a times, so these two cancels off, and 3x times 4 is 12x. Now if you look at this function and I ask you what's the domain, you would say it's all real numbers, but that doesn't really matter. What matters is it comes as the product of these two functions. If anything cannot go into inside one of those functions, it cannot go inside here. So that context makes the domain this. So it's not the domain of the domain of what you see, it's a domain of the the intersection of the domains of the two original functions. Okay, so that is very important. It's not this one right here. It's not the domain of that. Okay, now let's go to another question. Now also I need to say that there are some questions in this section that you don't know how to find the answers, so we will defer those sections till later, but you just need to know the process. Okay, so find the domain of this for fx equals 2x over x minus 1 and gx equals that. So let's find the domain. So remember, the domain of f over g is equal to domain of f intersection domain of g intersection all the x such that gx, the bottom function, equals 0, not equals 0. So the bottom function cannot be equal to 0 as well. Okay, so let's find these three things. So the domain of f is, you look at the function f, that would be anything but 1. So x minus 1 not equals 0, so x not equals 1, that would be negative infinity to 1, then 1 to infinity. Domain of g is, well, you look at this, well, there are two domain restrictions. There is a square root and there is the denominator. So for the square root, x plus 1 should be greater than or equal to 0, so x is bigger than or equal to negative 1, and that would be negative 1 to infinity, but x not equals 0 because this guy cannot be 0. So together with that, you should get negative 1 to 0 and then 0 to infinity. If you're not really sure about that, you draw a number line, negative 1 to 0, negative 1 to infinity is here, and then you also drop 0. So this part and that part. Okay, so also gx equals 0 at where x equals negative 1. So x not equals negative 1. Well, gx equals 0, yeah, at x equals negative 1, so x should not be equal to negative 1. So look at all these domains. This domain right here, this domain right here, and this domain which is negative infinity to negative 1, and then negative 1 to infinity. Now how do you find the intersection of all three? So that's df, this is dg, and the last one is this domain. Well, I would use logic, or you can use colors. Okay, so if you just use the logic, you can see from here you can't have anything below negative 1. So anything below negative 1 is excluded, and also you cannot have 0. And here you cannot have 1, so you should exclude 1 from here. And from here you cannot have negative 1, so you should exclude negative 1 from here. So you should get the answer negative 1 0, 0 to 1, and then 1 to infinity. Now that, if that was confusing, you can use colors. Now how do you use colors? So let's use colors here. So the first domain I will denote by blue, and then the second one by orange, and the third one in purple. Okay. So in blue, the first domain, that would be negative infinity to 1 and then 1 to infinity. So that's 1. let's leave a gap here, just this a small point, but okay. Okay, and then the second one is in orange, -1 to 0 and then 0 to infinity. So -1 to 0 and then 0 to infinity. So -1 to 0 is in orange and then 0 to infinity is in orange. Okay, and then in purple, -infinity to -1, -infinity to -1, okay, and then -1 to infinity. Now have a close look at which things have all three colors. Now -1 has orange, has blue, but this purple parenthesis, it doesn't have purple. Anything below doesn't have orange, so it should start from -1, and then it has all three colors until you hit this point where it doesn't have orange, so to 0. Okay, and then you would go from 0 until you can see all the colors until here you don't have any blue, so 0 to 1, and then again you can see all three colors until you hit infinity. Well, you don't hit infinity, but you know, that's how you denote that. So when it's really confusing, you can always, you know, fall back to colors, and that should work. But you know, when you do enough questions, most of you should be able to do the thing without using colors, do the thing without just by looking at it. All right, let's move on. Okay, so let's start with the question, and let's see how you do the question. All right. Okay. So select the choice. I will just do this quickly. The function is 2x minus 2, so that's 2 times x minus 1. Gx is that, so f over gx is 2 times x minus 1 divided by, so 1. That's a small fraction. You know how to do fraction division. Flip it, so x plus 1 over x minus 1, tick tick, you get 2 times x plus 1. But the domain is domain of f, which is all real numbers, domain of g, which is x not equal -1, and then gx equals 0, that's this, at x equals 1. So x not equals 1. So x cannot be 1 or x cannot be -1, which means the domain should be -infinity to -1, -1 to 1, and then 1 to infinity. Okay, so let's move on. Find those functions. Find the functions, the compositions, and the respective domains. And these are the questions I said there might be no answers. You might not be able to find the answer in this lecture, so I will defer them. Okay, so if I can do it, I will do it, but if I cannot, I will just defer it. All right, so find the functions and the respective domains. So f o g x. Remember how we do it? We need the domain of the inner function. And the domain of the answer. Okay, so domain of the inner function and the domain of the answer, and here the domain of the inner function, that would be g, and that would be 1 minus x greater than 0 or equal to 0. That would be negative x greater than or equal to negative 1, or x is less than or equal to 1. So that would be negative infinity to 1 including. Okay, so let's see how we get the answer. Now for this you have to find the composition. Okay, so that would be f of gx, which is this. So f of square root of 1 minus x. So you plug in square root of 1 minus x whenever you see x. So square root of 1 minus x squared divided by square root of 1 minus x squared minus 1. That cancels the square root, so 1 minus x over 1 minus x minus 1. So square root of 1 minus x over negative x. That's it. So that's the function f for g. And the domain, well, there are some complications. From the top I get negative infinity to 1, as we got this one, the same exact calculation. Here I get x not equals 0. So with both of these, I get the domain should be negative infinity to 0, and then from 0 to 1. I have excluded 0 because it's in the denominator and it can't be 0. Okay, so with this, now I can see that the domain is negative infinity to 1, 0, and then 0 to 1. So this intersect this. Let's say this is domain of the answer. So dg intersection dA. Now you can use colors. I'm not going to do colors because of time restraints. So that would be negative infinity to 0 and then 0 to 1. Okay, so let's see G of F. Okay. Now G of fx. Now again we are looking for the domain of the inner function. Okay, that would be G of fx, and that would be G of x over squared minus 1. Okay, and you will be writing the square root 1 minus then this guy. Okay, so how do you simplify this? Well, you can use the least common denominator. There's nothing there. Okay, so sorry about it, it just looks very blurry now. Sorry. Okay, so let's use the square root. So x minus 1, I would do x squared. So now I can do x squared minus 1 and x squared minus 1 minus x. How? Now with this, that's square root of x squared minus x minus 1 over x squared minus 1. Unfortunately, we don't know how to find the domain. So we can defer this question to lecture 19. This part, just this part, So some questions right now there are no way for you to know. Okay. Let's move on. Find the functions f for gx and g of x for this, and also f of fx. So three stuff. So f for gx, g of x, and f of fx. So f for gx. So you will also need to find the domain of gx, because g is the inner function, and gx is square root of 1 over square root of 1 minus x. So now, because it's in the denominator, it cannot be 0. It also, the inside should be bigger than 0. So 1 minus x greater than 0. Compare with the previous question. It was in the numerator, so it was greater than or equal to. So you get x is less than 1, so that's negative infinity to 1. Okay, now let's see what we get when you do the composition. So f of gx, so f of 1 over square root of 1 minus x, which is f, now you just plug in square root of 1 minus x whenever you see x. So square root of 1 minus x divided by square root of 1 minus x, 1 over minus 1. Okay, so let's see what we see here. Well, it is very familiar, because you have also seen this in the exam. What you do is you multiply everything by the LCD, and you can see how things cancel off. So what you get here is 1 over 1 minus square root of 1 minus x. So that's your f or gx. The composition is 1 over 1 minus square root of 1 minus x. Now before this class we found a lot of domains, so you should be familiar at least up to a certain level to how to find the domains of functions. Now this one is not that easy, but this says 1 minus x is greater than 0, which is x is less than 1, and this whole thing says 1 minus square root of 1 minus x is not equal to 0. So that would be 1 not equals square root of 1 minus x. Square both sides. 1 not equals 1 minus x, so x not equals 0. So x is less than 1 and x is not equal to 0. That would be negative infinity to 0, and then 0 to infinity, 0 to 1. So now you might be feeling a little confused, but you know what, the only way to master this concept is by just doing this yourselves. Okay, but I would suggest doing the WebAssign homework first. The written homework questions for this is really challenging, so you might need some help from the TAs or from the tutors, but the WebAssign homework is quite straightforward. So the intersection of the domains is negative infinity to 0 and then 0 to 1. Okay, now let's do g of fx. Okay, so g of fx. Now I need the domain of f, because now the inner function is f, and my f was x over x minus 1, so x minus 1 not equals 0, x not equals 1. So that would be negative infinity to 1 and then 1 to infinity. Now it doesn't matter which format you use. you can use anything, but at the end you have to express in interval notation. Okay, so this would be g of fx, which is fx is g of x over x minus 1, and that would be, whenever you see x, you would plug in this whole thing. So 1 over square root of 1 minus x over x minus 1. Let's simplify this. LCD. Here. X minus 1, x minus 1. So you get x minus 1, well, 1 over x minus 1 minus x over x minus 1, which gives you 1 over square root x minus 1 minus x over x minus 1, which is 1 over square root negative 1 over x minus 1, which is 1 over square root 1 over 1 minus x. Flip it, you get square root of 1 minus x. Whoa. So the last step is you flip it. If you really want 2 more steps in between, now the thing is I can't really reinvent the wheel every time I do these type of questions, but let's see. You get 1 over 1 minus x, and then you flip it. So 1 times square root of 1 minus x over root 1, which is that. Okay, so with this, the domain is x is greater than 1. You can just work it out yourself. Okay, so that would be 1 to infinity. That domain is 1 to infinity. This domain is negative infinity to 1, and then 1 to infinity. Use colors or use logic. Either way, you should end up with domain of f of g is 1 to infinity. Okay, so let's do the last one, the domain of f of f. So I don't have enough space there, so f of f x. So f is x over x minus 1. So the domain of f is x not equals 1. So let's see what happens when you do f of fx. F of fx, which is f of x over x minus 1, which is, plug in this whenever you see x in here. So x over x minus 1 over x over x minus 1 minus 1. Now that's a complex fraction. So times x minus 1 here, x minus 1 here. So now you can see how things cancel off. So you get x divided by x minus x plus 1, that is just x. So yeah, I mean it is fast. You can just slow it down, or you can just look at it and see it for yourself how I did that, but I ended up with x. So there's no restriction here, and the restriction here is x not equals 1. So together with these two, x not equals 1 is the domain. So this is the domain of A, the answer. So domain of the composition is domain of f intersection with domain of the answer, which is negative infinity to 1 and then 1 to infinity. Okay, so let's do one question and move on to the next section. All right, so I hope you got that right. The idea is, well, very similar. So f of g, f of gx is equal to f of 1 minus x square root, and that would be 1 over, when you see x you plug in 1 minus x, so 1 over 1 minus x. The domain is x naught equals 1 here for dA, but we need the domain of the inner function dg, which is x is less than 1, so that would be negative infinity to 1. So df of g is equal to domain of g intersection with the domain of the answer, which is negative infinity to 1. Okay, so at least if you remember that you had to look at the domain of the inner function, you should be able to get this question correct. Yes, this question. All right, let's move on to composition of three functions. Now it says find the composition and its domain. It becomes too complicated at this level. Of course you can do it, but it's just a little too complicated, and it doesn't give you new knowledge about anything. Okay, so you just do the composition 3 times. So first let's find f of g of hx, which is the same as f of g of hx. Now hx is square root of x, so that would be f of g of square root of x. Now g of square root of x, g of x is x squared minus 5, so plug in square root of x in there, so f of square root of x squared minus 5, and that would be f of x minus 5. And f of x is 1 over x, f of 1 over x is f of x minus 5 is 1 over x minus 5. So it's just a bunch of simplifications. If you go in order, you should be able to get it. But I'm not thinking of the domain. You can just try to do the domain yourself. Okay, let's move on. Let's do an application question. Now this was very similar to one we did in class, if we have time. Also, this question is I will test this question in the at the end. So the next question is about very similar thing. We have a sphere instead of a circle. So an oil tank is leaking, causing a circular pool of oil with expanding radius r, given by radius equals 1 plus t square root. Now you know you have a circle of radius r. The area is pi r squared, right? But it's given that r is equal to, well, rt is equal to square root of 1 plus t. Now that is the radius. So radius is given by 1 plus t square root. So this is square root of 1 plus t. So you plug that in. So you get a equals pi square root of 1 plus t squared, which is pi times 1 plus t. So this is the area of the region after t minutes, area in terms of t. Okay, now we can just answer the questions we have next. Find the area of the spill when it was first discovered. Well, now that would be t equals 0. So we have the equation pi times 1 plus t, plug in t equals 0. So you get a equals pi times 1 plus 0, which is pi. And what's the area 3 minutes later? So you plug in 3 here, a equals pi 1 plus t, and you plug in t equals 3. So you get a equals pi 1 plus 3, which is 4 pi. So once you find the function in terms of t, everything else is just plugging in numbers. Alright guys, so that's the end of this lecture, and I hope you enjoyed it, and I hope you learned something. Also, please do the domain questions. First start with the WebAssign questions and the written homework, as I said in the middle of the lecture. it's quite difficult. So come by my office hours tomorrow. That's Thursday. Okay, and then let's do the question on the screen. Okay, very similar to the one we did right before that. So you get v equals, it's given here, 4/3 pi r cubed, and r equals cube root of t plus 1. So v equals 4/3 pi cube root of t plus 1 cubed. So 4/3 pi t plus 1. Find the formula that gives the volume of the balloon after t seconds, and that's that. Alright, thank you for watching this.